So this is the work energy theorem, and let's do a little bit of reviewing. We do know that work causes a change in the energy of a system by transferring energy between a system and the external world. Okay, so in the last unit, we talked about how work is force times distance, and specifically if we're looking at the net work done on an object, it's the net force, all right? So it's in the direction of the displacement of the object. So that is what work is. So work is really a force. The thing is, force is really caused by, or a net force. If you have a net force not equal to 0, we know what's happening to the object. We know it's accelerating, right? And if an object's accelerating, then there's a change. And where does that change occur? In the velocity. Our velocity is changing. So if something is causing an object's velocity to change, it's causing it to accelerate, it's because there's a net force. And if there's a net force occurring, then we know that there's either being work added to the system or work taken away. So we're talking about energy being added, energy being taken away. So however much energy an object has is how much work you can do. To give an object energy, you have to do work on it. So for example, if I'm pushing a cart, right? So I'm starting from rest, I start pushing a cart. I have now added energy because my net force is in the direction that the cart is moving, okay? So I've added that force, I've added work, so energy is in. And notice, if I'm adding energy to a system, my speed is going to be increasing, okay, because I'm adding energy. Now let's say I have that cart in motion, and then I let go of it, right? An object in motion wants to stay in motion, right? However, once I let go of it, what's going to make it come to a stop? The friction, right? So then I have negative work, right? Because the net force, when I'm not pushing the cart, but it was in motion, that net force is now going to be friction. It's an opposing force. So now my cart is losing energy, and my speed is going to decrease. So, you know, we did the kinematics, we did the forces. We are now taking the extra step to tie in both of those and talking about how does acceleration work with force and work with energy and work. All right, so we have this work energy theorem that says that the net work done on a system is going to be the change in your kinetic energy values. All right, so we have this, so we're going to do some applications with this first of all. And then next, I do want to talk about the work done on versus work done by. So this is going to come up in example 5, but similar to forces, if you're applying a force to an object, there's an equal and opposite force being applied in the opposite direction, right? So work is the same way. If you have a work being done by an object, so work being done by object 1 is going to be opposite the work done on object 2. So if your 2 objects, the work done on those are equal and opposite. So this will come up later. So let's go ahead and do a proof so you guys can see how they figured out this work energy proof, how this work energy theorem kind of came about. So we start with this kinematic equation, right? We have an object accelerating, so we have 3 kinematics. We're going to focus on that third one. And let's go ahead and multiply both sides by whatever object's mass that we have. So I have 3 terms. I'm going to multiply them all by m. So I still have my 3 terms. What I'm going to try to do now is I'm going to get my displacement term by itself. So that means I'm going to move this one. So what do we need to do? Just subtract. Good. Okay. Mass times acceleration. What is that represented by? Newton's second law. What is mass times acceleration? Net force. So now we have mv squared minus mv naught squared equals 2, but instead of mass times acceleration, I know that that's really just the net force. And then I'm going to divide everything by 2. So I'm going to take half of everything. So this is 1/2 mv squared minus 1/2 mv naught squared. Half of 2 is 1. So that's just the net force times the displacement. But what is net force times displacement? Net work. And what is 1/2 mv squared? K, kinetic energy. And what is 1/2 mv naught squared? The initial kinetic energy. And here's our change in kinetic energy has to be the net work done on a system. Okay? So when we're talking about net work, we're saying, you know what, how is our energy changing? All right, now kinetic is the energy of motion, right? So if we're talking about a change in speed, that's going to give us the net work because the change in speed is going to give us a change in kinetic energy, and that change in kinetic energy is going to be the total work done on the system.